It's really wonderful for me to have a chance to talk to you on this subject. I enjoyed so much my visit yesterday and having a chance to talk to so many students in particular about the future that it has me feeling like I'm sort of walking about 1.5 feet off the ground. So thank you for that inspiring visit. As President Hull said, I've been a scientist for almost 30 years. And I feel during that time I've been part of what anybody would have to say is an explosion. There has been an explosion in the creation and the generation of knowledge in that period of time that is unprecedented. And it's a time that's been an incredible explosion in the advancing of technology. And probably the biggest difference is the interconnection, the way people can communicate, not just office to office, school to school, but country to country across the globe. And that explosion is something that is not going to stop. It's just going to increase. And I want to talk a bit about that today because as all that knowledge and all the connection and technology has changed, it's changed very much the way we even think about science and technology going forward. And of course that means we need to adjust the way we think about educating people to be able to be leaders and participate in this, I'm going to call it a knowledge revolution or a knowledge explosion. In my experience, as Chris said, as a professor, a practicing scientist, life scientist, as a teacher, and as a university administrator, I've learned a lot about how things work. And I think looking at the way things have changed over that 30 years, there's probably 5 things that seem really clear to me and obvious, I'm sure, to you. And first of that is that there is this knowledge revolution, and people even calculate the number of new material added each year that is exponentially growing. And so that's a big change. Just keeping track, keeping up with knowledge is impossible. So anything we teach a student today is going to be probably wrong or obsolete 5 years from now, maybe even 3 years from now. And so we have to figure out what it is that we teach people isn't specifically to master all the knowledge. It has to be something else. It has to be teaching people how to master the ability to accumulate knowledge and look at the next, the upcoming areas. I look back every once in a while at my old notebooks from my beginning chemistry and biology classes, and first of all I go, who wrote this? You know, who remembers all that? But also it's just not the same. So that's a different challenge than it was even when I was going through school, and it's certainly something that changes how we teach. Second is the sciences now are a web of interconnected and dynamic fields. And, for example, to be an environmental biologist, which I consider myself, I'm actually probably more trained as a chemist. I should be a better physicist. I do mathematics. I've got to spend a lot of time talking to people, so somewhere I better understand something about social science. And if I'm going to do it really well, I should know a bit about the humanities and poetry and art, because the only way you're really going to reach people is coming at them from all of their capacities. So we are interdisciplinary in a way that we've never been before. When we hire biologists in our biology department, they may not even have degrees in biology. They're going to be coming from other areas because these fields are expanding. So we teach disciplines in universities, but we work cross-discipline in the real world. So that's something to think about. How do you get away from thinking that you master a single field when realizing that you're never going to face a problem that can be handled by a single discipline? That's a big change. I think the third big change is that science and technology of the future is really at its best going to be used to solve what I would consider urgent global problems. That means it crosses geopolitical boundaries too. We don't work on things just from the perspective if it's environmental, of our local community. Usually the issues that we address are highly interconnected to the societies that we live and often to the global climate, the global environment, and the global political situation. So that also argues to be really well prepared as a scientist requires understanding something about economics, understands history, understands global relationships, because they're all part of this system-related world where we need to think of things in a very different way. I think the fourth point that I want to make is that to be a leader in the world, a leader in your community, a leader in your society, every generation going forward is going to have to understand discoveries in the sciences. These are discoveries that are unleashing incredible potential. But with that, they're unleashing major ethical issues, issues of our times that we need to understand so we don't become victims of the science we're creating, but we become masters of these discoveries and we use them in ways that we believe to be important and believe to be the right way to use them. And there isn't a person being trained now that should not have a basic level of science literacy going forward. And I think this is something that in America we're not grappling with as well as we should be. The literacy of our own communities is declining in a way that 25 years ago we would have thought shocking. And so that's not something I hope to see duplicated in a country that's trying to set itself moving forward. And it's certainly not something I hope persists in my own country, and it's really important. The fifth issue is that the problems themselves, as I talked about earlier, are interdisciplinary. And so it means that someone that may not think they're good at science can still have a very important role to play in the understanding and the transfer of science and technology to the community. You know, so you don't have to be a physicist to still have something to do with technology. On the other hand, physicists can also have a lot to do with other aspects. Many physicists, by the way, actually go into things like business. And it's quite interesting, this mix that we're seeing in our country, and although it may not be happening here yet, it will be. And so it's going to be very interesting as you develop that. One of the first and most important issues is that science is only going to develop through collaboration. This is one of the wonderful things I think about being an academic, that in spite of wars and differences of opinion, differences of every sort, scientists have always, and educators have always tried to collaborate. We're one of those few areas where instead of competing, we try to share everything. Now that doesn't mean special rights don't go to certain new technologies, but if you go to a meeting and you ask someone what they're doing, they'll tell you everything. Because we've learned for years that the only way to build knowledge is to share knowledge. It is a really wonderful, open, deep aspect of the way education works and the way science and technology work at their best. And so collaboration is important, and it's essential, in fact. And so I want to take a moment to talk about the collaboration that Dartmouth has developed with this wonderful American University of Kosovo. I'm very excited about this partnership because it gives us both an opportunity to learn from each other in this wonderful development of your university here and your country, and also for us as we're learning how to work across the globe and work in different places and with people using technology to communicate, as well as wonderful visits like this to get to know people. We have a 5-year agreement with the American University in Kosovo, which was preceded by an initial 1-year phase. And we see ourselves as engaged advisors and also as collaborators, and hopefully we're in this for the long term. I feel very optimistic and hope that at the end of 5 years we'll be able to continue that commitment to work together. We're very grateful for the work of so many people, and I do want to take a moment to thank some people on behalf of my colleague Laurel Stavis. Many of you have met her. We were so pleased to have the opportunity to meet with President Yayaga, and she expressed so clearly her support for the university. We met with Minister of Health Farid Agani, again very supportive of the activities here, very excited by what you're doing. We at Dartmouth have already hosted the former Minister of Health, Bukyar Bukochi. I'm trying hard to say these names right. And we also have to thank the Minister of Education, Rambuya, and his predecessor, Over Hojai. Now these are all people who have been working with us, or we hope to work with going forward, and very actively involved with your university. There was also lots of work done just to get this partnership going between Kosovo and particularly the Dartmouth Medical School, where we have hosted, I think, more than 200 exchanges with young physicians. And I'd like to thank Ilir Hoja, Dr. Ilyana Baraktari, I'm sorry, I just skipped, Ditiria Hoja, and colleagues at Dartmouth Medical School, many of whom have been here, I think including Dr. Jim Strickler, Dr. Joe O'Donnell, and Dr. Mike Zubkov. I'd also like to thank Richard Lukai, the chairman of the American University and the Kosovo Board of Trustees, and the wonderful new Foundation for Mothers and Babies, and Brian Bowen, the academic director here, and Ilir Ibrahimi, the chief operating officer, and I think we're going to be able to host him in Hanover in November, and Bill Weschler, the vice president for program development, and a member of Dartmouth's class of 1978. And I'm an adopted member of that class, so I call him my classmate. And of course, to President Chris Hall, who has shown such visionary leadership with this institution, making it such an exciting partnership for us. So thank you for letting me mention everybody, and thank you for those wonderful collaborations. So we look forward to continuing those friendships and links for the development of your young nation and our old school, 250 years in 2019. So it's fun to be the elder in that partnership. It reminds me, when I think about the challenges ahead and the opportunities ahead, about something one of Dartmouth's past presidents, John Sloan Dickey, said. He became president of Dartmouth right after World War II. And he was a visionary because he came to Dartmouth and he said, you know, the most important thing for the next generation is to get people out to understand the world. We've just come back from a war, and the Americans that went there didn't have the slightest idea what the rest of the world was like. And we want to make sure future generations are going to understand the world. And they started programs so that 70% of the Dartmouth students study overseas for at least one term. And that started more than 50 years ago. But at the time when he welcomed students to campus, he would say to them, "What you are is what Dartmouth will be." And this is true for Kosovo now. What you young people are, the youngest country in Europe, is what your country will be. And I think that's quite a privilege for us to be able to take part in that wonderful time. So I'm just going to talk a little bit now about how I think science and technology should very rapidly become a big priority going forward. And I know sometimes when you think about all the needs of a country, developing science and technology might seem like a luxury, something that you don't want to invest in. But I think that the sooner that the country can invest in the education of people in this vital area, the better, because there is no doubt, absolutely no doubt, that the countries that move ahead in the future are going to be those countries who have carved out a niche in areas of science technology, and certainly who have made their populations completely literate in the areas of science and technology. So it's not too early to start thinking about this for its great importance. I'm an environmental scientist, as Chris said, and so for many years my students and I have studied things like movement of heavy metals in fresh water, things like arsenic and mercury, cadmium, zinc, and these are major issues in your country. I'm sure I don't have to tell people about that, you all know. But it's not just the movement of metals in water, it's water in general. Many people think water resources are going to be the next oil. The battlegrounds of the future could come about in how we preserve, protect, and use oil. So certainly technologies early on in a developing nation that are designed to both preserve sustainable use of water, clean up water, make clean water available, and do it in a new, not wasteful way are going to be critical here. And that is going to need science and technology to be part of that conversation. It's also obvious that we need to learn from each other. These technologies for working in desert climates, they're going to come from all over the world, from China, from Australia, from southwestern United States. So getting out there and bringing partners who are developing new traditions for working in water, cleaning water, are going to be a really important part of that partnership. And the really wonderful thing is that scientists that work on this want to go other places and help. That is something that is a wide part of our whole ethos when we're trained is that if we have a tool that we think is good, we want to take it someplace else and put it to use. So I think that's something to remember going forward. Another area of work that I do is on Atlantic salmon. And I mention this one because it demonstrates the interconnection in the world just for both the creation and the solution of problems. So Atlantic salmon, as you probably know, have natural breeding grounds that go all up and down the coast of the North American coast and all up and down the European coast. So you can get Atlantic salmon populations in Spain, up to Norway and Finland. You get them in Canada, down to parts, at least originally, down to the parts of the Midwestern United States. In recent years, they've really declined, in large part because people have built dams, so they can no longer go upriver and breed. But there's been a major international effort to restore Atlantic salmon and keep these populations thriving. But their numbers have declined. And the reason they're declining now is that the water temperature of the ocean is changing. When salmon come out into the ocean and they need to grow and develop into large animals before they come back to breed, they go up and they spend their time up in the northern waters of the northern Atlantic. And just a slight change in temperature of 1 or 2 degrees in the North Atlantic can completely alter the patterns of current movement, the movement of their food, the zooplankton and the small fish that come from the bottom up can be changed. And so their numbers have dwindled, their sizes are smaller, and these major populations of one of the most wonderful animals in our world are declining. And it isn't there is no solution that any one country can do. It's a solution that has to do with the will of the world to address climate change. And we know very much that it's anthropogenic, human-driven origins of climate change are only going to be solved globally. One thing that I do know from being provost at Dartmouth, where we're doing a strategic plan, for us we're trying to look at our next 250 years, but we'll start decade at a time. But we've decided science and technology is absolutely critical to us. We can't be a leading research institution educating people, leaders for the future, if we're not trying to make them very conversant in science. And that's because we think the solution to so many problems affecting the human condition, as well as the long-term quality of life on the planet, are rooted in the sciences. You know, there's some great examples just to talk about what's changed so quickly that I think are really interesting, important questions. So for example, we're able to understand biological processes at the molecular level. And by understanding at the molecular level, just in the last 5 years, it's revolutionizing medicine. We're moving to the place where we can start treating people individually based on aspects of their genome. This would have been unthinkable 10 years ago. It could have complete change in the way we give medicines to people, the types of medicines, where they target. This is going to happen so quickly. And the people that come to Dartmouth and work at the Dartmouth Medical School will have a chance to work and learn about that, but that's going to be very important. We're on a threshold of understanding the brain in a way that has never been possible before. We can get to the point of localizing what part of your brain is responsible for remembering a noun, what part of your brain is responsible for fear, what makes parts of your brain develop at different rates so that young men and young women might act very different at different points of their life and development. That's not only really critical for us as people, it's affecting the way we think about education and how we link learning directly to changes in the brain. And it's just wonderful stuff that people, even down to the level of undergraduates, are starting to get to do. So partnerships with universities that do that will be very important because it's something that can be shared. I'll talk in a minute about how you can share that opportunity. We're at a critical time in the history of the planet where the changes in biodiversity I find immense, incalculable losses that could be happening as we continue to develop the planet in the way we have been developing it. We're putting in place another mass extinction event. It's something at the rate or the scale that the planet hasn't seen for about 65 million years. That's pretty sobering, how quickly we can change things like biodiversity. So we need a biological basis for understanding it and an urgency to really think about preserving biodiversity. And you might want to preserve it for lots of reasons. Some of it might just happen to do that, like me, you love every species for almost its sacred nature. On the other hand, there are very strong economic and medical and other reasons to preserve our biodiversity too. So there's a lot of reason to address that question. We've placed our ecosystems under enormous stress, and to the point where our health and our economic welfare is threatened by pollution. This is certainly something that you're thinking about here, and we think about in many places of Europe, Asia, the United States. And these are areas, though, where there's a lot of good collective thinking that can help us restore some of our damaged systems. I mean, of course, it's much better not to damage them, but we're not going to give up and say they can't be restored, or we're not going to find a way to try to bring them back to be healthy and vital. That's what the future will bring for us, and I think we'll see changes in that in the next 2 or 3 or 4 years. We're going to see advances there. So it's exciting to be involved in science and technology and higher education. So one of my statements to all of you is, even if this isn't your area of interest, keep abreast of it. Try to take every opportunity you can. It's great that you came to a talk on this, even if you're not a scientist, because the more educated you become on it, the better able you will be able to place yourself in industries and in nation building in a way that you can bring some of this power to bear. Now, when we think about what's changing educationally, the big change is how students need to learn. So if it's all collaborative and it's all these different areas of work, we need to make sure students aren't learning in the old model, where you're just basically you learning. You read your material, you take a test, you read your material, you take a test. Because actually, as a scientist, you would never work by yourself, coming up with all the answers. So we're developing whole new ways of teaching that involve teaching in teams. And as you build buildings these days for learning, we build buildings to be completely wired. We want to have workstations all around the building so that people can work in teams and work on those workstations. And in not too distant future, you might have a professor on that workstation sitting here at the university who's actually in Dartmouth running some experiments on an fMRI about the brain. And the students in this lab here in Kosovo are talking to the students over there in Dartmouth as they look at data coming off that machine. And they're sharing it and going, wow, you know, they're interacting over it. What does it mean? What do you think? So that you become working teams. You can see each other. You can talk to each other. It'll be as easy to negotiate as YouTube. And it isn't nearly as expensive as recreating every one of those opportunities in a small location. So we're going to have disparate laboratories all around the world connecting in hubs that are the classroom of the future. And that future is not very far away. And as you think about your new campus, that is a future you can create here right away. So it's a new way to think about how you can do science and technology, because you can do a lot of it virtually, because it's about the interaction over it that is going to be just as important. So these are going to be discoveries and ways of teaching that are going to be very, very exciting. People will be able to interact in lectures across the world, and you'll be able to post in chat. There'll probably be something much more interesting than chat sessions. I do want to make a point, and especially I think that's important here, but it's also important in America right now too, that science stimulates economic growth. There's just absolutely no doubt about it. Our big science, in America, the science is funded through federal agencies. One of them is the National Institute of Health, another is the National Science Foundation, the EPA, Environmental Protection Agency. They give out hundreds of millions, in fact billions of dollars that support our science. We're very lucky. We have the most money going into science of anybody right now. But they give it out through these agencies, and they've calculated recently what the impact of some of that money going into science has had. And they estimated that in just the last year, they produced 500,000 jobs, which resulted in $68 billion in economic viability based on the money that they gave out from NIH just last year. So it isn't that it's so costly, it's got a return on investment that is actually much greater than many other types of return on investment. And so that's another reason. That doesn't mean that in Kosovo you're going to develop in every area either, but you can pick strategically particular areas where you may find this to be very important and develop those technologies or partnerships with those technologies that could be very important in generating jobs and economic growth. And it takes people a while to believe it, but once they start seeing the results, it's very important. Then the last point I want to make is that not all technologies are going to be expensive. And this is very important. We tend to think of biomedical, all these things as being in big, huge buildings that cost millions of dollars. But the truth is, some of the best technologies are the ones that are being developed for the least amount of cost. And in fact, some of those technologies are not coming from the developed nations. They're going back out into other places and trying to adapt technologies that are already in use and very reasonable to do things in a way that they can fit better with the economy of many countries. So I want to give you an example because it's one of students. There's a competition every year run by the US EPA where they ask students to design something, an innovation in the area of sustainability. And the group that won last year came from the University of Illinois at Champaign-Urbana. And it was a team of 5 students, and they proposed and built a new type of water filter to provide safe water for what could be millions and millions of people on the planet. And the main thing they were trying to do is make a filter that would also would deal with all the waterborne pathogens that were causing things like diarrhea and hepatitis, transmitted worm infections. They had to have a good filter. But they also wanted to make sure that they could eliminate chlorine, because a lot of these filters were using chlorine, and chlorine is not a good thing to drink. And it's also not a good thing to send down into the watershed, into your rivers. And they found that they could adapt sand filters that were being used by people to develop a complete new kind of system made in the lab, and instead they used iron oxide particles that would be mixed with the sand. The iron would bind to the sand, it wouldn't leach out, you wouldn't be drinking lots of iron, you wouldn't have to add chlorine, and in fact it would kill the viruses, it would block the worms, and it would be an extremely effective method. It was successful when they tested it with people. They looked at the quality of water, and it looks like this small invention by 5 students could actually impact some 3 million people currently and up to millions more in future generations. And it can very easily provide a business for the local economies that can build the filters and sell them for a cost that's reasonable in their own community. Their vision has precedent. There was another similar low-cost, different option filtration system that used silver, which isn't quite as good as using iron because it's more toxic. But that they did these in clay pots because these pots were used by people to store water, and that resulted in 35 small factories in 18 countries already producing the pots for the local community and cleaning their water. So, you know, it's very important to realize there's lots of ways this is going to develop. So I've talked about being collaborative. I've talked about trying to teach in a new way. I've talked about the fact that you can work with partners that have a lot of money to do things that you can't do, but you can also do inventions that don't cost a lot and can be applicable to your local community, all through science and technology. And the last thing I want to make, point I want to make though really is, but it all relies on human invention. And so for us who have ever been in a classroom, we know where that sits. That sits in the seats of our students, and I would say in the heads of our faculty. These are people that want to work with you. It's about developing that human potential and spurring creativity, because there's no idea, there isn't a single idea for the future that's going to come from anything but somebody's brain working together with somebody else, starting on an idea, questioning the idea, and working on that idea. So if you're going to invest in anything, you invest in education that can bring people forward. Now I think in my brief meetings with the leaders of your country that I already was fortunate to meet, that they believe that. They share that vision. And I think they're looking at you here at this university to help lead the way, because your graduates are already out there making a difference, and you have immense opportunity in the next year, 2 years, 5 years to continue to help show how that great experiment of education is always working. And so, you know, I look at this and I think, how fantastic for you. So I just want to say I really appreciate being here. I would love to answer questions. I spend untold hours reading about science and technology, so I'm happy to talk about it. But also I just want to say thank you and for having me here and having a chance to talk.